Today we're going to be looking at some of the questions from Test 1 of the College Board SAT Blue Book. Now, I went through the first test and I pulled out 4 questions that are all ranked a 5-level difficulty, meaning that they're the hardest questions apparently in that section. So what we're going to do is we're going to take these 4 questions and we're going to make them very, very easy using some simple strategies, logic, or just simple facts that knowing for the SAT could be really, really helpful. So let's take a look at this first one here. So this first one comes from Test 1. It's Section 3 and Question 20 on page 401. It says a salesperson's commission is K% of the selling price of a car. Which of the following represents the commission in dollars on 2 cars that sold for $14,000 each? Now, normally this would seem like a really tough question, especially with variables in there, and a lot of people don't know where to start with this one. This is where using the simple substitution strategy can make this very, very easy. So instead of having K% of the selling price of a car, we're going to choose a value for K. And I recommend either choosing 100 or 50%, or if you're good, you can use 10% as well. But for simplicity's sake, why don't we choose 100? Let's say that K equals 100. So now let's go back and let's reread this. A salesperson commission is 100% of the selling price of a car. Which of the following represents the commission in dollars on 2 cars that sold for $14,000 each? Well, we had car 1 that sold for $14,000, and then we had car 2 that sold for $14,000. Okay, so total, the price was $28,000. Okay, now what do we do with that? Well, let's look at what the question is asking. Which represents the commission in dollars on 2 cars? Well, the salesperson's commission is 100%. So he's getting all of it. He's making 100%. He's making $28,000. There's our answer to the question. Now all we need to do is match our answer here with the answer that we came up with when we used K is 100. So let's substitute back into our answer choices. K is 100. So in this case, it's 280 times K, which we said was 100. And you could see this comes out to be $28,000, which is the answer right off the bat. So this strategy makes this very, very easy. You can go ahead and you can check all the other answers. You can see that 7,000 times 100 doesn't even make sense. 28,000 times 100 is going to be way too large. If you go down here, it's going to be 14,000 divided by 300, which doesn't go in evenly, so there's no way that will work. And then in adding 100 and dividing by 100, that doesn't make sense at all. Okay, so the only one that does work is choice A. There's your answer. So you took a seemingly tough question here and using a simple substitution strategy made this much, much easier. Let's take a look at the next question here. So this comes from, again, Test 1. It's Section 7, Question 8, found on page 415. And it says, in an election, 2.8 million votes were cast, and each vote was either for candidate 1 or candidate 2. Candidate 1 received 28,000 more votes than candidate 2. What percent of the 2.8 million votes were cast for candidate 1? Okay, now many people, they're going to start this off. They're going to split candidate 1, candidate 2 into 2 columns. It might look something like this. They might have candidate 1 and then candidate 2. And they'll say, oh, okay, well, candidate 1 received 20,000 more votes. They'll say the number of votes plus 28,000. And then they'll give candidate 2 X number of votes. And then they'll go ahead and solve it using all this math that's going to take a really long time to do. And there's a much, much easier way to do that. So I want to show you that much, much easier way. So let's go here and let's identify some things with this problem. 2.8 million votes were cast. Okay. Actually, let's write that over on the side here. Okay, 2.8 million votes were cast. So here's our votes. Now I want you to realize something else here. Candidate 1 received 28,000 more votes. So candidate 1 received 28,000 more votes. Now, if you look at these, I'm sure you can see some kind of similarity between these numbers. And I also want you to notice that your answer choices are all percents. Can you see a relationship between these two numbers? Well, if you know some simple things about percents, you should be able to see this. And I'm going to explain this little trick right here. Let's imagine there was a decimal place at the end here. If you move that decimal place over once, that will give you 10% of a number, because you're simply just dividing here. This is 1/10, so 1/10 would be moving the decimal over one time. If you move the decimal over another time and place it right here, that's going to be, I should use a different color for that. Let's change this to green. Okay, and place the decimal there. That gives us 1%. So if you move it twice, you get 1%. If you move it once, it's 10%. And you can see if we move it twice, we end up with 28,000. So we can say that 28,000 here is actually 1% of the votes. Knowing that, now we can reread this question, which says candidate 1 received 1% more votes than candidate 2. So candidate 1 received 1% more than 2. Okay. Now let's go and let's look at our answer choices here. Question says, what percent of the 2.8 million votes were cast for candidate 1? Well, let's just think about this. Let's say candidate 1 received, let's start with E, 55% of the votes. That would mean candidate 2 must have received 45% of the votes, simply because the number of votes has to add up to 100%. If we look at choice D, if candidate 1 received 51%, then candidate 2 must have received 49%. And we go to choice C, if candidate 1 received 50.5%, then candidate 2 must have received 49.5%. And B, if candidate 1 received 50.1, then we have here 49.9%. And here 50.05, then candidate 2 would receive 49.95%. So now let's answer the question. Where did candidate 1 receive 1% more than candidate 2? Well, this is a difference of 10%. This is a difference of 2%. And right here you can see choice C, that's a difference of 1%. There's our answer right off the bat. So you don't have to go and do all this complicated math out if you can realize that there's a connection between these numbers, 2.8 million and 28,000. As soon as you see, oh, well, this is 1%, sorry, you can see this is 1% of 2.8 million. It becomes a much easier question. All right, let's look here at Test 1, Section 7, question number 18. This can be found on page 418. It's a function question, and this is actually a very, very, very easy question if you know a little bit about functions. Okay, so it says the graph above shows the function g, where g of x equals k times x plus 3 times x minus 3 for some constant k. If g of a minus 1.2 equals 0 and a is greater than 0, what is the value of a? Okay, if you can remember a little bit about function shifting, this question becomes really, really easy. So I'm just going to review this real fast here. If you said, why don't we use g of x since we're using g of x? If I said g of x, I'm just going to make up some number here, plus 3, that's going to shift my function up 3 units. If I said g of x minus 3, that would shift it down 3 units. And if I have g of x plus 3 on the inside here, that's going to shift my function to the left 3 units. And if I had g of x minus 3 on the inside, that's going to shift it to the right 3 units. So take a look at this function. It says g of a minus 1.2 equals 0. This is the key line right here. We're finding out when it equals 0, or basically think of this as when y equals 0. You can think of this as kind of g of x equals y. You might have heard like f of x equals y. It's the same thing here. So we're looking when y is really 0. Well, in the normal function here, the original function I should say, we could see that it's at that point, and it's at that point right there. So this is our point 3, and this is our point -3. But now we're shifting this function. A minus 1.2 means that we're shifting this function to the left 1.2 units. So, I'm sorry, to the right 1.2 units. So let's go ahead and do that. Let's shift this to the right 1.2 units. So if we did that, now the 3 is going to end up at 4.2, and the -3 is going to end up at -1.8 at 0. So your answer here is simply 4.2, because we're looking for when a is greater than 0. So that's going to be this point out here. Simply knowing the function shift makes this question very, very easy, knowing that you're just shifting it to the right 1.2 units. Finally here, we're looking at Test 1, Section 8, Question 15. This can be found on page 424. Again, this is ranked in 5 difficulty, but can be done very, very easily using simple strategy. Again, I would consider this a substitution method here. Let's read through the question. It says, if the length of a rectangle is increased by 30% and the width of the same rectangle is decreased by 30%, what is the effect on the area? Okay, so let's say we had a rectangle here. Now, whenever you're dealing with percents, you always want to start by choosing 100. So I'm going to label everything important 100 on this rectangle. Or if you want, if it makes it easier for you, you can use 10. But for simplicity's sake, I'm going to use 100. It's good to get in the habit of using the same number. So if we go ahead here and realize we're looking for the area of the rectangle. So if I'm looking at the area of the rectangle here, area is simply length times width, I will wind up with 10,000. Now why I chose 100 is because it makes it really, really easy for this next part here. It says, what happens if the length of the rectangle is increased by 30%? So now I have another rectangle here. The length is increased by 30%. Well, if the length is 100, 30% of 100 is literally 30. So all I need to do is add 30 to 100, and that's why I choose 100 as my starting point here. Now this becomes 130. And then it says, and the width of the rectangle is decreased by 30%. 30% of 100 is 30, so now I'm just subtracting off 30, which would be 70. Now I simply just need to find the area here. Multiply length times width. 130 times 70 is going to give me 9,100. So right off the bat, you can see what happened to this area. Clearly, we started at 10,000 originally, and then our area went down to 9,100. So it's clearly not unchanged, and it definitely didn't increase. So even if you had no idea what to do next here, you would still be able to have a 50-50 shot of getting it right just on this knowledge right here. But there's a few ways you can see what's going on here. One way is to simply divide your new by your original. So I could take the 9,100 and figure out what percent that is out of the original, which is 10,000. And with some easy math here, I'm going to simplify this. You could see it's 91 out of 100, which is 91%. So this rectangle is 91% of this rectangle, which means that we must have simply lost 9%, because we started at 100% and now we're down to 91%, so we lost 9% here. Another way that you could do this, if that way was a little confusing for you, is to find the difference between these two numbers. So 10,000 and 9,100, the difference would be 900, and you simply put that out of your original amount, which is 10,000. And that will show you how much you lost. Again, we simplify this down, and you get 9 out of 100, which is And there we go. So that's simply how you can solve some of the hardest questions on the SAT using some basic strategies or just some basic logic or simple things that you should know about functions. Hope this helps, and good luck on the SAT.